Okay, so I would like you to try to start setting this one up on your own. We're going to definitely start with the left side, so I'm going to go ahead and write that down. Secant of theta times cosecant of theta minus cotangent theta times cosine theta. It's definitely the more complicated side, and we're going to try to rewrite that. So pause the video right now, rewrite it on your own, and then come back and check. Okay, so secant of theta you should have rewritten as 1 over cosine theta. Cosecant of theta is 1 over sine of theta minus cotangent of theta, which is cosine of theta over sine of theta, times cosine theta. So when you look at this cosine theta, it's really, you can think of it as cosine of theta over 1. And so when we rewrite this, we can just put the second part into a single fraction. So when you multiply fractions, you multiply the tops and the bottoms together. So cosine times cosine is cosine squared, and sine times 1 is just sine. So you'll notice those now have the same denominators, which means you can just add them together. In this case, it's really subtraction. 1 minus cosine squared theta over sine of theta. All right. So there's that identity we used before, 1 minus cosine squared theta. That's equal to sine of squared of theta. And that's all over sine of theta. At this point, you can cancel out one of the signs. So you have 1 over cosine of theta, and then you just have one sine of theta left. So you have sine of theta divided by cosine theta when you multiply those two together. And that's equal to tangent of theta, which is what we were trying to get to. So that checks out. Okay, next one, we're going to start with the left side again. Cosecant of theta minus sine of theta. So rewrite that. Cosecant, 1 over sine, minus sine of theta. So again, in order to combine these, we're going to have to get a common denominator. So we're going to take the sine of theta and multiply it by sine of theta over sine of theta. So it has that denominator sine of theta. When we multiply those together, we get sine squared in the numerator. So we have 1 minus sine squared theta all over sine of theta. 1 minus sine squared, kind of like the other identity we used in the last problem, is cosine squared. So it's cosine squared theta over sine of theta. Let's look back up at what we're trying to get. Cosine of theta times cotangent. We notice we have a cosine in the numerator here, so let's go ahead and pull that out. Cosine of theta, and then times cosine of theta over sine of theta. Our final step then is to rewrite this cosine of theta over sine of theta, and you should recognize that that is cotangent theta. There's the bell. That's not your bell. It's not time to go yet. Cosine of theta times cotangent theta, that's what we were trying to find. So we're good to go. All right. Next problem. Sine of theta over cosecant theta plus cosine theta over secant theta equals secant squared theta minus tangent squared theta. So this sine of theta, we're going to take that and we're going to divide it by cosecant of theta, which is 1 divided by sine of theta, plus cosine of theta divided by 1 over cosine of theta. And so when you take sine of theta and divide it by 1 over sine of theta, you really want to multiply by the reciprocal. So it's sine of theta times sine of theta, which would be sine squared of theta. Plus, same thing with the cosine, you get cosine squared theta. If you add those together, hopefully you remember that, that's 1. At this point, it seems like you might be kind of stuck. And so it might help you to look back up at what we're trying to get to. So if you need to, you can write this down at the bottom, secant squared minus tangent squared, and try to find a way to get back up to 1. Now hopefully you remember there is an identity that involves secant squared and tangent squared, and that is tangent squared theta plus 1 is equal to secant squared. So this is our little thought bubble over here. If we want to make it look like secant squared minus tangent squared, we'll subtract the tangent squareds from both sides. And so we'll just get 1 equals secant squared minus tangent squared. So what we already have is actually true. 1 is equal to secant squared minus tangent squared. So there's nothing else we need to add in. You could go back and do secant squared as like 1 over cosine squared, and this is sine squared over cosine squared, and do all that. But you really don't need to. We're really just done there. Make sure that even if you work backwards, your equal signs are all lined up. You should show all your steps, like so when I go to grade it or someone else reads it, they can read it all the way through, and it's not going from like side to side. Okay, next problem. Sine squared plus cosine squared over tangent equals cotangent. So hopefully, again, bells are going off in your head. Sine squared plus cosine squared is 1. So this is just 1 over tangent x. And 1 over tangent x is equal to cotangent x. And we're done. So that was a really easy one. And I'm sorry, I've been a little lazy. You should probably rewrite this left side first. I've been a bad math teacher. All right, we've got a few more. All right, next one. Secant of theta plus 1 times cosecant of theta minus cotangent theta. Start out just the way we have before. I'll rewrite it this time. All right, so secant of theta, 1 over cosine, plus 1. And then times cosecant, which is 1 over sine of theta, minus cotangent, which is cosine over sine of theta. All right, so to start out here, we have 1 over cosine plus 1. We would like to try to get those together, and so we would have to change the 1 to a cosine over cosine, so they have the same denominator. So that would end up being 1 plus cosine of theta all over cosine theta. Now make sure here you don't cancel out those cosine thetas. You can't cancel them out because this is 1 plus cosine, not 1 times cosine. In the second set of parentheses here, we notice both of those fractions have the same denominator, so we can just go ahead and combine them. When you multiply two fractions, once again, you just multiply the numerators and the denominators. Oops, I don't need that. Okay. Up at the top, we want to go ahead and FOIL that out. You might also recognize that it's kind of like the difference of squares formula, so you might see a shortcut. But if we FOIL it, we'd have 1 plus cosine theta minus cosine theta minus cosine squared theta. So the cosines cancel out. We're just left with 1 minus cosine squared theta all over cosine of theta times sine of theta. 1 minus cosine squared theta is sine squared from the Pythagorean identity again. We keep using that. And that's equal to cosine times sine, the denominator. All right, we can cancel out one of the signs. And so we just have sine over cosine. Sorry, I'm running out of space. And that is equal to tangent of theta. And we're done. All right. Let me see. Oh, there's the rest of my space. Okay. So the next one, go ahead and pause and try to do this next one on your own. Okay, no, seriously, pause. Did you do it? All right, let's check it out. Start with the left side, tangent of theta plus cotangent theta. So that's equal to sine of theta over cosine theta plus cosine theta over sine of theta. We need to get a common denominator. So this left fraction, we're going to multiply by sine over sine. So we'd get sine squared theta over cosine theta sine of theta. This fraction on the right, we're going to need to multiply by cosine of theta. So we'll get cosine squared theta over cosine theta sine of theta. We can go ahead and put that in just one single fraction then. Sine squared theta plus cosine squared theta all over cosine theta times sine of theta. That's equal to 1 over cosine theta sine of theta. Now, at this point, let's look back up at what we're trying to get to. Secant of theta times cosecant of theta. So we're going to need to separate that into two parts. So we can separate this one fraction into 1 over cosine theta times 1 over sine of theta. Just like that. Okay? Because remember, when we multiply fractions, we just multiply the numerators and denominators together. And 1 times 1 would be 1. And then 1 over cosine is secant of theta. And 1 over sine is cosecant of theta. And that's all done. One last problem. Oops, I went too far. All right, this one's going to be a little bit more complicated. I'm going to start on the left. Cosine of theta over 1 minus sine of theta minus cosine of theta over 1 plus sine of theta. All right, so you might be able to tell the first thing we want to do is find a common denominator so that we can add these two fractions together. This fraction on the left needs a 1 plus sine of theta. So we're going to multiply both the numerator and the denominator by 1 plus sine of theta. I'm going to actually write all this out. Same thing in the second fraction, but it needs a 1 minus sine of theta. So minus cosine of theta times 1 minus sine of theta. Make sure you're writing your thetas as you go, okay? So you should not be leaving off your thetas when you write these like cosine and sine. Even though we may not say it all the time, they're really there. Now that these have the same denominator, I can go ahead and combine them in the same fraction. I'm not going to do anything with the numerators yet. I'm just going to put them together in one fraction. I'm not going to distribute anything. All right. In this next step, I'm going to go ahead and distribute. So cosine times 1 and cosine times sine. And the same thing over here. Make sure you distribute the negative when you do that. You also need to simplify the denominator in this case. We have 1 minus sine of theta times 1 plus sine of theta. You can FOIL that out, but you should just get 1 minus sine squared theta. Again, it's kind of like the difference of squares. All right, let's try to simplify this. Up here, you notice the cosine of theta and the cosine of theta canceled out. We have 2 cosine sine thetas left. All over 1 minus sine squared theta. But actually, we know what 1 minus sine squared theta is. So let's go ahead and rewrite that. 1 minus sine squared theta is cosine squared theta. So one of our cosines can cancel out, and what we're left with is 2 sine of theta over cosine theta, which is 2 tangent theta. And that's it. All right, I hope you enjoyed this. I hope you didn't miss me too much. It is now time for your exit quiz after this, so get it from the sub and then turn it back in, and then do your IP. Email me if you have questions.